Oh, sorry. At 11 o'clock, we're going to have a fire drill, right? I don't.
Yeah.
Yeah.
I think,
It's on a Thursday, last Thursday. Right, so let's check where we are. We did reduction equipment. We actually finished materials. We're on module 4 now, right? Yeah. And module 4 is actually.
we're halfway through metal.
We only went on to metal.
Yeah, we stopped
But we
actually.
never carry on there.
Okay. Not
I
fair.
think, yeah, we started
Copper
on
alloys we didn't stop.
We started by nickel and
lead,
yeah, that's all.
lead, yeah, copper, nickel. I think it was
Oh, copper alloys.
Yeah, we were
Right,
getting
right,
copper
right.
alloys.
Okay.
Yeah.
Alright, so. These dates. But in terms of syllabus coverage for chem plant, we okay, right? It's just that the chemistry is taking us a bit longer than we should, right? But we're not bad. Right? We're supposed to finish 2 modules, so we've got that. In chemistry, in the next lesson, we're going to be starting acid and bases, right? It's actually not a bad module at all. It's quite a nice module. All right. So we stopped at copper and alloys. Thanks. Right, so everyone, we know what's an alloy, right? It's a mixture of metals. And then we looked at the videos in terms of why we actually mix metals. To ascertain certain properties that can be used in industry, okay? And we're now looking at copper and alloys, right? Copper and its alloys are widely used in the chemical processing, particularly where heat and electrical conductivity are important factors. And I think it asks, well, remember in the test we had a question, what is a good conductor or something?
Yeah.
Right? So copper is widely used for electricity. Sorry, page 30. We're on the page 30. At the bottom there, copper and alloys. Page 30. Yeah. Alright. Right, so we said that we know that copper is widely used because of its electrical properties, right? Also, we need to realize that copper has excellent heat properties. Right? So that's the good, 2 things that you need to remember about copper. It's particularly used for its heat and electrical properties, or electrical conductivity. So that note there, you can highlight it if you want. Right? It has high corrosion resistant properties, right? So that's an advantage of copper to industrial and marine atmospheres, like seawater, alkali, and solvents. However, oxidizing acids rapidly corrode copper. So it has advantages. It can act on seawater. What's seawater, guys? Yeah, no, I mean, what's the compound?
NaCl.
NaCl, right? So, in terms of NaCl, like our seawater, it can withstand oxidation when put in seawater. But what it can't withstand is oxidation while in acids, right? What happens when it's put in acids? It starts to corrode easily. And you've seen the corrosion of copper, or you would have seen like old coins.
Greenish.
It turns green.
Yeah.
That greenish color is actually oxidation occurring on it. You can actually remove that there if we use an electrode, right? And we create an oxidation reaction, and we can remove the impurities, right? So let's look at the first one there, brass. Now, does anyone have brassware at home?
Yeah.
All right. In terms of brasses, right? It has 15 to 40% could be zinc. So it can be any of that, from the range 15 to 40% can be zinc, right? Brasses with up to 15% zinc is ductile but difficult to machine, but have a corrosion resistant properties equivalent to copper. Brasses with 20 to 40% zinc, right, have a lower corrosion resistance and subject to de-zinkification and stress corrosion cracking, especially when ammonia is present, right? There's a question that comes out about the zinc 15 to 40%, and then you have to know in terms of a brass, if it contains 15% zinc and 40% zinc, what are the differences? That was a question that came on the exam, so let's highlight that there and write exam question: difference between zinc brass with zinc 15% and brass with zinc 40%. There was an exam question, right? Alright, everyone's got that down. Let's move on to the next one. Bronzes. Right? Kaya? You got the bronze? Oh no, you got better than a bronze, eh? Silver. Yes. Yeah. Okay, yeah. So in terms of bronzes, right, and phosphor, it is a mixture of copper and tin, SN, right? It had corrosion resistance equivalent to copper, but better tensile strength. They are difficult to machine, right? So both the brass and the bronze are difficult to machine. That's what you need to highlight there, from there. It has a similar mechanical properties as brasses. However, it does not get affected by stress cracking, while brasses do, right? In comparison with aluminium and silicon bronzes, the latter are very popular in the process industries because they combine good strength and corrosion resistance, right? Yeah, so this year, I don't think a question came out before, or maybe in the multiple choice, can't remember though. But what we, towards the end of this, this booklet, we're only going to be working with past year papers. You must be so familiar with the past year papers that you should, like, know the question. Although, because it's like theory based, and if you answer enough, you'll see there's a pattern, but they're asking the same questions over and over again. Alright? Especially on this material side. They ask specific questions on specific materials, and they just change it up now and then. Right? 3.3.4 copper and nickels, right? With 10 to 30% nickel. It has the highest corrosion resistance of all copper alloys and fine application as heat exchangers tubing. Resistance to seawater is particularly outstanding. But these ones with nickel, it doesn't say here, but it's expensive. You can write that down. Disadvantage, expensive. You want 3.2.
It's difficult to
That's right.
machine.
It's expensive. Sorry?
The brass is difficult to machine.
Yeah, so if you bending it into, like, in terms of like machining, what they mean is they're gonna make a special piping with it, or use it in a plant for a tank, right? It's difficult to actually create this here. Yeah.
Oh, it's not like it's.
In terms of its properties of ductility and malleability, right?
Because when I say machine, I thought like on a lathe.
Sorry? Where now? Oh. So so sharp this thing.
Once it's done, we do the thing.
Okay. Alright, come guys.
Don't forget to switch off.
Guys at home